Hello, ladies and gentlemen. Welcome to section 5.6, graphing inequalities in two variables. Uh, so some stuff we need to know. Graphing in two variables is exactly like graphing in one variable. There's only a couple slight changes, and it deals with the same principle with the open circle, closed circle that we dealt with in section 5.5. So it also deals with the idea of shading. Okay, so make sure you're paying attention to that. I'll show you how to determine if we should shade or not, um, and we'll go from there. Okay, so we have three different examples here that we're going to go through. Uh, we have this first one is y is greater than 3x plus 2. We can see that it's already in our correct format. And so we start at 2, then we're going to go up 3 and over 1 each time. And so we'll just make our dots here and go through that way. Okay, so we've got our dots forming our line, and we see that this is a greater than sign, so we're going to use dashes to draw our line to make our line complete there. So it's a dash line because it's not the ordered pairs that can make this inequality true cannot fall on this line because of the inequality. So now we're going to determine which side we need to shade. And so what we do is we pick a point, and it doesn't matter where the point is as long as it's not on the line. And we pick a point and we test it if it's true or false. Okay, so the easiest thing we've got is we've got y is greater than 3x plus 2. The easiest thing that we can do is pick the point 0, 0. Okay, and so what that means is we have the point 0, 0. So we put in the 0 for the y, and we put in the 0 for the x, and we simplify this equation. 3 times 0 is 0. So we have 0 is greater than 2. Is this true? Hopefully all of you are saying no, this is false. So what that means is any point that is on the same side of this line of 0, 0 will not work. But any point that's on the opposite point, or on the opposite side, on this side over here, will work. So we shade this side. Okay, so we shade this other side here, and that's the side our solution is this whole shaded area. So if you want to try it with a point on this side, we can do -2, -2. This is just to prove that it does, in fact, or -2, +2, sorry. And so what we would have is we'd have 2 is greater than 3 times -2 plus 2. So we have 2 is greater than -6 plus 2. 2 is greater than -4. That's true. Okay, so we can see that this point works, which means every single point here works. So that's the side we will shade. The easiest way to do it, though, is to do 0, 0. If it's false, shade the other side. If it's true, shade that side. Okay? So going through, this was our first example. Let's take a look at the second example. The second example gives us 2x minus 3y is greater than 3. So we have 2x minus 3y is greater than or equal to 3. And we can see this is not in y is greater than or equal to format, so we need to make it that way. So what we're going to do is we're going to subtract the 2x. We have -3y greater than or equal to 3 minus 2x. We divide by -3, divide by -3, -3. we have y now is less than or equal to, because of this flip, this flips. Remember that from 5, 5. We have negative 1 plus 2 over 3x. Okay, so this is our new equation that we're now graphing. So we start at negative 1. We go up to 1, 2 over 3, 1, 2, 3. And we graph there, 1, 2, 1, 2, 3, 2, 1, 2, 3. Okay, and since this is a greater than or less than or equal to line, we are going to draw our line solid, no dashes this time. Okay, and you can notice that I make my line all straight all the way through, and that helps with the idea of the whole shading aspect as well. So now we have to determine, if which point, which side we need to shade. So as we said in the early example, we always pick, the easiest one to pick is 0, 0. So we start with 0. 0 is less than or equal to negative 1 plus 2 times 3 times 0. We have 0 is less than negative 1 because this goes away. And this is a very similar situation of what we had last time. This is a false statement. So that means we can't shade this side. We shade the other side. So we sit and we shade this side down here. Okay, and you can get as creative and as dark with the shading as you want. You just have to show me that you can shade that area. Okay, so let's take a look at this third and final example. In this third example, we see a different situation. We now have x is greater than negative 2. In all of these, we've always had two variables. Now we only have one. Okay, and this we could say, well, you could graph this on a number line, but no, it's asking us to graph this on the coordinate plane. So if we remember, x is equal to negative 2 right there. Okay, so that's where our first dot's going to make. But this is something that is an undefined slope, which means it's a vertical line. So all of our points are going to go straight up this way and straight down this way. So we have a vertical line at negative 2. Since this is a greater than symbol and has no equal sign to it, we make our dashed line going all the way up and our dashed line going all the way down. Do not connect the lines or the dots. So we make our dashed line this way. So now the only thing that we need to do is we need to pick our point, which we like to pick 0, 0, or you can pick 1, 0, or whatever you want to pick, but we have the point 0, 0. We only put the x value in to there, so we say 0 is greater than negative 2. That is a true statement, which means we are going to shade the side that it has the point 0, 0. So we shade this side, and that's going to give us our final graph. Okay, so this is graphing inequalities on the coordinate plane with two variables, sometimes with one. If you have any other questions, make sure you let me know. Have a good day.